Hello, my name is Aiden Kurtek, and today we're going to be learning how to find volume using calculus. Specifically, we're going to be finding volume using by spinning a shape around an axis. To spin a shape around an axis, we need to first know from where to where are we actually spinning. And to do that, we're going to be specifically for this problem, we're using an x-axis. So we're going to be needing x bounds. You would need the bounds to be the same as your indicator of a rotator. So we're going to need to find those for future steps, specifically integration, which we're going to be taking the area of a circle and then adding up a lot of those areas together. And that is basically integration, adding up a lot of smaller things to one whole thing. Some handy background knowledge is graphing algebra 1 and understanding how to integrate. It's not necessary, but it will help. We're going to be today finding the volume of y equals 4 minus x squared and x-axis rotated about the x-axis. So the first step is actually like visualizing this. So we're going to be graphing it on an xy system. So we're going to be drawing a rotator around the axis and drawing lines perpendicular to our bounds and axis of rotation. Then we're going to showcase that there's a small dx here. Remember this for later, it is going to be important. But right now we're just going to display it as a small little box. And now we're going to quickly draw our shape. So it's kind of like an M&M shape almost, or like two contacts squished together. If you guys have any other ideas of what this could be, please let me know. So the next step is going to be integration. Actually, I lied. We need to actually find the bounds first. So we're going to be setting our two equations equal. X-axis, or in other words, y equals 0, equal to y equals 4 minus x squared. And this will give us the result of x is plus or minus 2. So now we're actually going to find radius and integrate. Radius is actually quite easy to find. It's just our top function minus the bottom function for normal area. But for this, it's literally just the top function. Simple as that. So now we're going to be actually using a circle area formula. So if you don't remember, it's pi r squared. So we're going to be taking a pi. And pi, one rule for integrals, if it's a constant multiplied by the whole thing, you can swing it up front. You can't do this for variables or something that's not part of all terms, but this also helps make it a little easier. And since this is also a symmetric function, I can actually take half the bounds and swing a 2 out front. This makes calculations much easier. Can't do this with every problem, and the practice problem specifically can't do this. So we have our radius, which is 4 minus x squared, quantity squared, radius squared, times dx. Dx is, so we're going to be adding up all those little sections, so we're multiplying by a dx. So now integration is undoing a derivative, which is basically finding the slope at a given point. So let's say here was like negative 16, y equals negative 16 was the actual equation, 16x. So this would actually translate, the derivative would be negative 16. So if you integrate it, it's undoing it. So you're going to go back to the 16x plus a constant. We have no idea what. We can find it for certain problems, but not with the given information we have. This is slightly different though. It's a definite integral, so you're taking one of these bounds subtracted by the other bound. It's a lot to take in, but everyone here is smart, so and capable. So I trust that you can understand this. All right, so we have from 0 to 2 at 2 pi, not at 2 pi, multiplied by 2 pi. And we're going to FOIL this out so we can actually integrate it. So we have 16 minus 8x squared plus x to the fourth dx. And for higher powers of derivatives, you would, let's say we were taking the derivative of x squared, we would swing it out front and drop it down by a power. So it would be 2x would be the derivative of x squared. So to undo that, we knock it up a power and put it over that number. So 2 pi multiplied by 16x minus 8x cubed over 3 plus, that's a little poorly drawn, but you get the idea, x to the fifth over 5, evaluated at 0 and 2. So this next step, we're going to be actually plugging it in. So we get 32, can't forget, do not drop your multiplier out here, 32 minus 64 thirds plus 32 fifths subtracted by 0 times all of that, which is just 0. And that's all in one section. I'm going to move my work up here. I'm going to move my camera over here. Alright, 2 pi multiplied by, this is really just 10, no, this is really just 21. That's really just 21 and a third. So when we add those together, we get 10 and 2/3 plus 6 and 2/5, which is 10 and 2/3 or 10 and 10/15 plus 6 and 6/15. We get 17 and 1/15. And multiplied by 2 pi, we get then 17 and 1/15. I'm just going to write down the step real quick. 2 pi. We get 34 and 2/15 pi. And that is the volume of this shape. Now, here is a practice problem you can try. Please let me know if you can actually figure it out. Bye. Have a great day. Thank you. Thank you again for listening to all I have to say. Have a great day.